Continuity is a local concept. In other words, it's the description of a situation at a point. So we say that a function f is continuous at a point C in the domain of f if this criteria is true. Okay, so this is the condition for f, the function f, to be continuous at a point C. Many functions that you know are continuous at every point in their domain. Lines, polynomials, sine, cosine, exponential functions, logarithms. Okay, notice when I drew all these functions, I could draw all of them without taking my pencil off the paper. So a function is continuous intuitively if you can just draw it, right, without ever taking your pencil off the paper. So here's an example of a function that's not continuous at a point. Right? Here's another example of a function that's not continuous at this point. Okay, so here's the point where this function is not continuous. This is the point where this function is not continuous. So let's explore these two functions which aren't continuous at C. And I'm going to define the value of the function, let's call this h at C, h at the point C. Let's just define that to be 0. And here, let's call this f at C equals -1. All right. We have in this situation that the right hand, the left hand and the right hand limit exists, and that the right hand limit equals f of c. So we have that the limit as x approaches c from the right of f exists, and it equals -1, which equals f of c. But this does not equal the limit as x goes to c from the left, which equals this value, which let's just say that's equal to 5. Okay, so that's why the function f at this point is not continuous. H is not continuous at this point because neither of the limits exist even, and that's enough for a function to not be continuous. As soon as a limit doesn't exist, then the function is not continuous at that point. So, for example, we can say that the limit as x goes to c of my function h equals infinity, which isn't a number, and it's certainly not equal to 0. So just an example of a function which is continuous, something like temperature. That's a continuous function. Temperature doesn't make a leap from here to here, right? There's a transition. Okay. Another function which should be continuous is distance, right? As you move away from something, that should be a continuous function. But something that isn't continuous, for example, would be, say, the price of bread. And that price doesn't move very quickly. So let's just say, this x-axis is in years. Usually it's some price, and maybe the next year it's a different price. Maybe it goes up a bit every year. But something like the price of an item, generally speaking, that won't be a continuous function. It'll behave like this. It'll increase, perhaps, but discretely.